Okay, so here's another example. This time we've got two functions that look very similar. First, we would like to decide what are the domains of the initial functions. And let's say here we've got x over x plus 1, right? So we're not allowed to plug in -1 there. If we did, we'd be dividing by 0. And the same for g of x. Okay, let's go ahead and add the two functions together. So I have f of x plus g of x. Okay. Now, we could just add the two that have common denominator. That would be enough. I'm going to go a little bit further just because this is what you should do when trying to solve problems, right? I want to have a common denominator. So I would multiply the top and bottom of this fraction by x plus 1. That's going to give me 4x plus 4 plus 2x all over x plus 1. And that's going to give me 6x plus 4 all over x plus 1. And I might even go a little bit further and take out a 2. Write it like that. All right, so just like the original two functions, all right, so x is -1 or can't be -1. So our domain for the final function is -infinity to -1 union -1 to infinity. Okay. What if we wanted to subtract two functions? Well, this one actually works out really nicely. Remember that f of x was 4 plus x over x plus 1 minus g of x, which is x over x plus 1. If I subtract, these two fractions here are the exact same, so they cancel one another, and I just get 4. Now, here's the weird part, and this might be where you really start understanding what we're talking about with the domains. The new function is just y equals 4. Okay, that's a line. However, there are values of x that we're not allowed to plug in because of the original functions. The original function said x is not allowed to be -1. And so the domain of the new function, even though it's just y equals 4, has to still be -infinity to -1, -1 to infinity. So if you were to plot that, for instance, right, y equals 4 is up here, you would expect that to be, right, everything. However, because of the restriction on the domain, it's going to be everywhere to -1 open, and then everywhere from there. So there's actually an open circle at -1. Okay, and that's because of the domains of the initial functions. All right, let's continue here. So we have f times g of x. All right, so f of x times g of x. That's going to be 4 plus x over x plus 1 times x over x plus 1. That's going to give me 4x over x plus 1 plus x squared over x plus 1 squared. All right, so basically I'm just doing these two multiplications. Now again, if I want to do a common denominator, right, this first fraction is missing in x plus 1. So I'll multiply by that, top and bottom. So now I get 4x times x plus 1 plus x squared all over x plus 1 squared. Multiply this. Combine like terms. And then finally, I might go ahead and factor out an x. You don't have to. And that would be my final answer. Now, again, you technically could have stopped back here because the domain of both of these rational expressions tells us that clearly x can't be -1. So the domain's the same as it was before. It's -infinity to -1, union -1 to infinity. Okay. What if we had f divided by g? So here we're going to do 4 plus x over x plus 1, all divided by x over x plus 1. Dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to take this and flip it over and multiply. When I do that, I can then multiply it to both parts. And when it gets multiplied by the second piece, right, it's nice because you have x plus 1 divided by x plus 1, x divided by x. This whole term becomes 1. So if you really wanted to put that together, or put it as one fraction, right, you could multiply 1 by x over x. And then that's going to give you 5x plus 1 all over x. So what am I not allowed to have there? Well, here, my denominator can't be 0, and so x cannot be 0. However, from the original functions, x is also not allowed to be -1. So I have to take all of that into consideration now when I'm writing my domain. The domain of the function then goes from -infinity up to -1, then from -1 to 0, and finally from 0 to positive infinity, right? So it's got two holes. It's not allowed to equal 1. It's not allowed to equal 0. Another thing to keep in mind, right, if you have two things that you can't equal, notice you have 3 partitions of the interval. All right, so that would be the domain of that function. All right, let's continue with a few more examples here. In this example, we're going to define f of x as square root of x minus 1, and we're going to define g of x as x minus 7. Find and write as a simplified rational expression. So I'm not going to concern myself as much with the domain. I'll go ahead and notate it for you. And if you have questions about that, let me know. But for right now, I just want to find and write the simplified rational expression. So I need to add these two functions together, right? This is what they're asking me to do here in this first one. So I will plug those in. And this is actually really easy, right? I can't add these things because the radical and the other terms in g of x are not like terms. So this is absolutely the best I can do in terms of the function. And what I did not do, and I shall do now, is talk about the domains, right? So the domain of g of x, well, g of x is a polynomial. So we know that that doesn't care. It allows anything from -infinity to infinity. The square root function can't be negative. So x minus 1 has to be greater than or equal to 0. or x has to be greater than or equal to 1. So for that one, the domain is 1 to infinity. This function is going to follow that as well, so its domain is 1 to infinity. All right, what if we were to subtract the two functions? Well, this one's also really nice, right? F of x minus g of x. That's the square root of x minus 7. I'm sorry, x minus 1. And then minus an x minus 7. And then if you really want, you can go ahead and distribute this. But again, none of these are like terms, so we can't actually add or subtract anything. One thing I did miss on this first part, right, this is x is greater than or equal to 1. So I actually need a bracket here. Okay, so let's just fix that. All right, this function's no different, right? It has the same restrictions that the two functions that comprise it had, and so its domain is once again 1 to infinity, and including 1. What if we multiply the two? Okay, so this is f of x times g of x, and I'm going to take the property that, right, I can commute these, because it just looks better if I write x minus 7 times the square root of x minus 1 as opposed to this, right? And this just kind of saves us from, any problems with saying maybe this x minus 7 might be under the radical, that sort of thing. So I just rearranged them. It's the same thing. And then if you'd like, you can go ahead and distribute. So this would look like this if you did so. Again, both of these have an x minus 1 under the radical. And so the only restrictions are the same as before, which are 1 included to infinity. The division is where we see a difference. So f of x divided by g of x. F of x is square root x minus 1. G of x is x minus 7. So the original functions, right? X could not equal, I'm sorry, x has to be greater than or equal to 1. And now we're not allowed to divide by 0. So this can't be 0, which means x cannot be 7. So x has to be greater than or equal to 1, and x cannot equal 7. So now my domain, combining those two, is 1 up to 7, not included, and from 7 on to infinity. Okay.